right, we're on. Hello. Hello, everybody. Welcome to people in the room and to people online. I hope you're enjoying Build so far. My name is Kim Bro, and I run the global partnership with Elastic. And hence, I'm super thrilled to introduce you in a moment to two gentlemen who's going to take you through what you're really here to hear about today. Some very exciting stuff. So thank you again for listening in. Before I do that, however, I want to anchor on a couple of things, a couple of perspectives from Microsoft. One is that partners make more possible. And also, we build a platform. I think if you heard through the keynote yesterday, that was one of the statements that partners or Microsoft makes a platform and partners makes it matter, and customers. So very, very full to let you know that that certainly holds true with Elastic. We've been working together for several years, and it keeps getting better. In fact, if you saw some of the keynotes yesterday, you heard probably Elastic was featured no less than 3 times, which is fantastic. And hopefully it speaks to how this partnership is anchored in co-innovation. I would thank everybody again for listening in. There's a very exciting session ahead of it. And with that, I'd like to present Jeff Fastow and Jody Bailey.
All right, thank you. Thank you for being here today. So I'm gonna hit this button real quick. All right, so yeah, I'm Jeff Vestal. I'm an enterprise architect with Elastic and a Gen AI specialist these days. So, you know, search has changed the world, and Elasticsearch continues to be the leader in search, and we've been doing this for over a decade. And it really is the de facto search engine for anyone these days wanting to implement a search application. But you know, search is more than just that search box that we all kind of think of. Search powered by Elastic really is everywhere. Even apps that you might not think about rely on search and require it. So you can think about analytics on log data, searching geolocation data, or analysis of your time series data. You know, even anomaly detection on your time series data are things that you can do with Elasticsearch in our machine learning platform. So you're going to hear a great customer story in just a minute with Stack Overflow, but a couple other customers that rely on Elastic to make their already amazing products even better. We have the Met Office in the UK. They use us to make weather predictions more accurate. Cisco, who everyone's probably familiar with, is using our vector database capabilities to speed up their customer knowledge-based search. Labelbox is improving the ability to train their LLMs, and Relativity, which is a large legal e-discovery company, is using Elasticsearch's vector search capabilities to build the next generation e-discovery across not only text, but images and video. So we hear a lot about the amazing capabilities of generative models. I know I've been having a great time the last year and a half, right, seeing all the crazy capabilities that come out. We saw or heard Sam Altman yesterday talk about even the next generation of models that are coming out, and they truly are. But when we're talking about business applications, what really makes these useful and kind of take to the next level for organizations is all the business data that you have. So the data that you've been using for your business analytics to make business decisions, this is all the data that these LLMs, for amazing as they are, unless you're kind of leaking everything on the internet, they haven't been trained on it. And so this is where you can really put that together. So a couple of examples. You can think of like customer information. So if you work at a place that sells products or services, anything that has customers, which most companies have these days, you collect data on the past purchases your customers may make, the locations where they either work or live or buy or ship, all that information, things that they own. If it's a services company, then what contracts are they contracting with you for, and what are you providing for them? So all these interactions with customers that, again, they're your proprietary data and they're not things that the LLMs know about, but you can combine that together to make a really personalized experience for your end users. Product details is an interesting one. So if you're selling products, again, or services, and even if they're listed on the internet, the models might know about them. There's a good chance, if you're a large e-commerce retailer, they know about them. But what they don't know is, the list of products, the inventory. So if you have different stores or different distribution hubs, what are the current inventory and quantities, for example, for each location in real time? What are the prices? Prices change all the time, sometimes minute by minute. And so what's the latest price? Are you running any promotions at the time? Is the documentation changing, support changing for that stuff? So all these things that, even if they're available on the internet for people to look at, if they change constantly and are updated, those are things that LLMs don't know about, because once they're trained, they're frozen in time until they go through another training cycle. And even things like process documentation. So service level agreements certainly are changed and updated over time, who to contract for what. And a lot of places have like documents that talk about how customers can self-service to perform some task for themselves rather than have a person. But you could take that knowledge, provide it to the LLM, and the LLM is really great at that, making that nice friendly answer for everyone to use. But you can provide the actual answers and the steps to ground the model and say, this is how you actually perform it, and perform that way. Because again, LLMs are amazing pieces of technology and advancement, but they do have their limitations. And while they're great for general reasoning, when you give them the right context, they make businesses and search applications pretty unbelievable. And so that's where Elastic can come in and deliver the most relevant content. You want to make sure when you're giving information to the generative models to ground them, you're giving the right answers. Because if you give them the wrong answers, they'll happily give you a nicely crafted answer that seems really accurate, but it's wrong. And sometimes it's funny. Sometimes you sell flights on airlines that don't exist or things like that. So there's just a range. Elastic has been a enterprise level company for years. So you can make sure you're securing all this data with enterprise level security and confidentiality. It's really important to, just like every other application you have that uses data, you want to make sure that the right people have access to it. And just as important these days, the data you're sending back out, whether directly to a user or to an LLM, you want to make sure you're sending data that's allowed to be sent out and not just blanketly sending everything out there. And then Elastic can help you reduce costs by, instead of sending a whole giant document to the LLM to ground it, we can help you find the exact passage or paragraph in a document that's the semantically nearest document. It can also work as a caching layer for generative answers. So if you have any kind of frequently asked questions or knowledge base where users tend to ask the same 100, 1,000, whatever questions over and over, we can cache those nice generative answers, and instead of having to spend your token costs to regenerate those answers every time, you can kind of shortcut that and give them back the already cached or generated answer, rather. So we've all probably seen versions of this type of diagram for RAG. I know we saw them at the keynotes the last day or two. So this is Elastic's version of that. And the way we kind of help ground LLMs and integrate with them is using retrieval augmented generation, or we kind of call RAG these days. And the way it works, essentially, you have the customer question. Before that happens, you've indexed your business data into Elastic. You can then use embedding models, which generate vectors for the data you want to be able to search semantically on, which I'll talk about in a minute. And then that question can be asked naturally. So instead of having to do keywords, you can let your user ask a question, right? Like, what's the refund policy on this product or something? You can just ask it naturally. Elasticsearch will run semantic search, vector search to find the documents that are most semantically relevant, or what they're really asking, and then return those to the application, so then you can build a prompt. And this is how we ground the LLM for the answers. You provide the answers in like a document, and you say, basically, the user's asking this question, the answer's in this stack here, you take it, process, make a nice friendly answer, and then that's what the LLMs, these generative models will do. So the way we help developers implement all this is with a set of tools we call the Elasticsearch Relevance Engine, or ESRE. So it's a set of tools designed to allow developers to really customize the search experience that their business is looking to create. So we have the ability to do textual search. This is what we've been doing for over a decade. So it's that text search we've all been doing for a long time. When you type in a bunch of keywords and you play the keyword game to guess what's at the end document, right? We're really good at it. We've been doing it for a while. But these days, we have the ability to run semantic search, vector search, and this allows you to ask those questions naturally. Sometimes there's a use case when you want the best of both worlds. If you have people who already know the keywords and they're good at that, that's great. Keyword search will work for them, but for most people these days, they want to ask questions. So we can combine those two search methodologies, which have different scoring ranges, automatically using hybrid search, using something we call reciprocal rank fusion. It combines them and then just provides a ranked order of documents. We have the ability to host your own transformer models to generate embeddings. I'll talk about that in a minute. And we also have a proprietary ML model to get up and running really quick, which I will also talk about in a minute. And then we can integrate with third-party large language models. So we're all at Azure today, so we can integrate with Azure's OpenAI. Even I saw that the GPT-4o model is out on Azure now. We wired it up yesterday, actually, or today, right when it came out. So you can get up and running right away. So you can, pass your questions right up to Azure, but you can choose your own large language model of choice. And if you're familiar with third-party tools such as LangChain, it's a really popular Python library used to build generative applications. Our engineers contributed the Elasticsearch parts of the library, so you get kind of the best of breed for using Elasticsearch in super popular and useful tools like LangChain. So, how all these pieces add up together, and there's a couple of things we'll look at to see how we can make this AI-powered search experience. Now, there's a whole other session you could watch in blogs and webinars that get into the deep context of what vector search is and how it's calculated and all that stuff. But for anyone new to this concept, essentially, it allows for faster, more accurate search results when you're searching, in this case, unstructured text data. And it allows you to use that natural language. So again, that's the ability just to ask a question like you were talking to anyone else and get back results that match. And the key value of it is not having to play, again, that keyword game. I like to think of, Google from the old days. You had to play the keyword game and like, what's the website going to say? And you iterate a bunch of times. But now you can just ask a question. And using these, transformer models, these embedding models that are created these days, excuse me, they make then vector representations of the text. And then you can use similarity calculations to find the nearest documents in its vector space. So documents that are closest together should semantically be close together. And in Elasticsearch, you can run the text embedding models directly within the stack, which again, I'll talk about in a sec. But you can also run vector search for images, audio, video, that's any kind of media out there that you can create vectors for. You can bring all those vectors into Elasticsearch and run vector search on it to find the nearest audio based on other vector similarity samples. Okay, I've mentioned transformer models a couple times. And you need to create a vector embedding. So you take the text, you run it through this embedding model, you get back a vector, which if you look at it, it's just a long array of numbers, either floats or ints. But those are coordinates in the model's vector space that allows it to run this semantic search capability. And so with Elastic, you can bring those models in. We support PyTorch models that are based on the transformer architecture. And this allows you to generate embeddings at search time and at index time without having to have disparate tools around where you have to create embeddings first at your search and then put them all together. And this allows you, again, to use the open source models that are becoming really popular on things like Hugging Face, and you can bring those directly in. And it really allows that varying level of sophistication where you can just go get kind of the standard embedding model out there, or if you start having a data science team that is making fine-tuned models for your particular data set, you can bring those models in and use them for vector search. If you don't have a data science team, or I know some companies have data science teams do some stuff, but not everyone wants to interact with a data science team. It's kind of fun when that occurs. If you want the easy onboarding ramp, you can use Elastic's proprietary model. It's a transformer model. It's called the Elastic-Learn Sparse Encoder. It's a sparse encoder model, which it's the same architecture. The output is just sparse vectors instead of dense vectors. It's a topic for a whole other time, but one of the advantages is you don't have as much RAM requirements to run it at scale. But it still brings state-of-the-art relevance to the Elasticsearch customer base. So if you have any general English text right now, where it runs on English text, it performs extremely well. And what I mean by general English text is any text that you or I in here could read and understand, as opposed to a very niche data set. But that's the majority of text search use cases out there, just kind of general English. And again, it performs extremely well, and you can deploy it with one click in the stack or through an API call, and then generate embeddings for all the text that you're doing. So it's a really easy way to get up and running if you just want to test it out, or you don't want to deal with ranking individual embedding models today. So we'll talk about vector databases and how they play into building a full search application. So all vector databases store and search vectors, kind of what they do. Most, or not most, but some vector database companies will also allow you to run embedding models within the stack, just like we do. Surprisingly, not all of them, but some. But what you really have to think about when you're building this is, as important as the vector part really is, you're building a complete search application. So you need to do other things than just search and return vectors usually, especially when you're interacting with humans. For example, I talked about hybrid search if you want to combine the best of that. But you can think about, so I'm from Chicago, I'm staying nearby in a hotel. If I'm looking for a pizza place, for example, and I want to search the reviews for, the most tasty, delicious pizza ever created, right? If you just run vector search and run approximate nearest neighbor search, it's nearest neighbor because it doesn't care if it's actually close. It will find the closest one, whether there's actually any reviews or not. So that pizza place might wind up in Chicago. I'm a little biased, but I'm going to say it's going to wind up there. That's great when I go home, but it doesn't help me when I'm 3 blocks from the convention center. So I want to use traditional search tools like filtering. So I can run a geo-aggregation filter so I can find those reviews that are with restaurants within a half mile of my hotel. I can use date range filtering, so I only want to find reviews that are less than 3 months old. I don't want to see that they were great 3 years ago. I want to see that they're still great. I can run aggregations then to find the categories of restaurants. Are they actually pizza places, or does it just happen to have pizza? And that gives you that little faceting box that you can return search results, and you can click the categories on the side to let users continually search down. Running autocomplete to help do suggestions, and all the other tools you see up there, including security. Again, it's important to keep reiterating. You want to secure the data. So when you're building a search application that's going to integrate semantic search, it's really important to not get hung up just on the vector capabilities. It's obviously an important component, but think of the complete search experience. And a couple more. So when you're traditional architectures, again, that we've been doing for years, you index the data into Elastic, you use BM25 for textual search. Anyway, we've been doing this for a decade plus. Inside that little BM25 box, I don't want to downplay it. There's a decade of engineering behind it. There's 100 little individual tuning tools you can do to really narrow your search. But essentially, you're running some versions of text search. And these days, again, you add in that extra step of having to create the embeddings. And if you run that model within Elastic, you can make the one call in to do that. And so with these embedding models, we really allow you the choice of kind of what range you're in. If you want to use a third-party model from Hugging Face that scores really well on the ranking charts there, that's great. You can bring those in and you can run them. If you have a proprietary model that's been trained up for your particular data set, or the easy on route is using Elastic-Learn's sparse encoder to just one-click install again. And again, Elastic's the leader in search and really help you build your Gen AI experience. There's one last point I want to talk about before I have this super short demo, and I'm going to hand it off to Jody, but it's one that's important. So vector database companies that are just vector database companies, they really like benchmarks. And because that's what they do one thing and it's returning vectors. So they should be fast. That's what they do, right? But again, as a human, I'm not really going to do anything with that vector. I don't know what to do with an array of over 1,000 floats. It doesn't help me out. I need the text back. And even if I'm interacting, I'm going to send it to a generative model, like GPT model. Those models take text as inputs. They don't take vectors, usually. So I need the text back anyways. So if I'm only focused on a tool that does KNN search, I have all these other things I have to do. I have to generate that query embedding, either at a third-party service or I have to run something myself and manage that. Again, I want the text back, so I'm not returning the vector. I have to find the text of the paragraph or the title or review or contract, whatever. I have to get that out somewhere. I might need to do those aggregations we talk about to find which categories things are in. I need to ensure access control to make sure that the right people are doing the right things and things are on. Filtering, geolocation, things like that. Personalization is a great one. If you have a site where people log in and they interact with you, it's great to personalize the results. I want it based on my experiences with you. Blending scores and all these other things. Or again, you can do this all through a call to the Search API. And that's kind of this whole part of it's really important to talk about all the pieces together. So I think I've talked for roughly 20 minutes. That's good. I have a demo. It's the shortest demo ever. And then I'll hand it off to Jody. I got to go. So we're in 3. Yes. Okay. So I have a little demo travel agency. A lot of us are traveling. So the reason I picked this demo to do it, all that stuff I was talking about, I'm going to illustrate it in 2 minutes in a little app. So I'm going to type in, is there a discount for multiple rooms? Okay, let me copy that. So I'm going to type it. So traditional search, we're looking at keyword searching here. So, I might remove some stop words. I might make that bigger. Sorry. Okay. I might remove some stop words. I might remove a plural. I might not. I might, stemming. But essentially, I'm looking for those individual words within my source document or, slices of them. And so when we look through the results, it's starting to ping off some individual words. Here's a discount. So I have to scroll down until I start talking about results, talking about discounts. It's not really the greatest experience. And you contrast that with semantic search, and in this case we're using the Elastic-Learn Sparse Encoder, but it works. This is what semantic search in general is getting at. I'm not looking for those individual words. I'm looking for the meaning, and the way the models do this, again, the simplified version of it, is it looks at the interplay of the words, how the sentence is structured, when words, the position, what they refer back to, and everything. And so I get the contextual meaning of what I'm asking for. So the first 2 results right away are talking about discounts. The first one's for groups, right? Multiple rooms, probably need to have a group unless I just like a lot of rooms. And so I get that right away, I get that. And so you have 2 options. Here I could just give that to the user, or is becoming pretty common these days to build chatbots. This would actually be the kind of behind the scenes first part of that RAG architecture where we run semantic search to retrieve relevant documents. And so I can switch over to a chat application. So this is first running the same question with the RAG part disabled. So this is essentially you going to ChatGPT or any web LLM and typing in an answer. Since it doesn't know my, my super secret business information, it gives a general answer. It's like turning to anyone in this room and asking, is there a discount for multiple rooms? They don't know where you're staying. They don't know if there's discounts. Like, yeah, there's probably discounts. I don't know. Find out where you're staying and ask them. But instead, we can go to enable the RAG part, and I ask that same question again. And so that first part is it's finding the documents that have those answers, and it grounds the LLM by saying, the user is asking this question, use the documents that I'm giving you to make a nice, friendly answer. And so, yeah, we get a nice answer. There's discount for groups 3 or more. It even gives me the email. I just have to email. I think it was yesterday's keynote. There was like 1 or 2 lines that flew by that I caught that said something like 75 or some really high percentage of people would rather use a chatbot than talk to a human. I'm definitely in that camp for various reasons. But you think about like you talk to a chat place that's busy, like any travel place, they're slammed. Like I have sympathy for the chat agents. But I've been in the rooms where they're doing that, and they have screens with like 10, 20, 30 chats open. That's why when you ask a question, you got to sit there for a minute or 2 because they're answering 15 other people. Whereas if you have a well-tuned chat application, it can answer questions really fast, and you can kind of iterate and go back and forth with them if you need to go back and forth. So not only do you get a quick answer, you also don't look silly talking to humans about things they should probably know, but you get a nice answer right off the bat. All right, so I've talked long enough. I'm going to hand it off to Jody. Let's see. All right. Switch.
All right.
I'll get out of your way.
Thank you, sir. All right, appreciate that. Exciting stuff. So Stack Overflow, my guess is most of you are familiar with Stack Overflow. Maybe have used it. In fact, the developer survey that we run every year says that 92% of developers use it every week. Now, I think maybe it's a little self-selecting, if you're taking the Stack Overflow survey. But what I'd like to do is, we're actually doing the survey right now, so I would love it if all of you would come out to stackoverflow.com and take the survey. It's really useful for the industry in terms of understanding the types of tools people are using, experiences that you're looking for, et cetera. So anyway, like I said, I'm sure everybody's familiar with stackoverflow.com. What you may or may not be familiar with is that we actually offer that solution as a product for businesses. So you can essentially have Stack Overflow within your organization. Now, what I'm going to talk about and demo here today is Overflow AI. And, about a year and a half ago, ChatGPT came out, right? And we all I heard loud and clear, certainly, Stack Overflow was going away. It was going to be replaced by ChatGPT. Also heard developers were going to be replaced, and none of us would have jobs. It'd all be done by AI. Thankfully, neither one of them seems to be true, at least not yet. But it really spawned us into action in terms of, okay, well, what do we need to do and how can we leverage the large language models? Like a lot of companies, we've done things with machine learning and AI for a while, but with the launch of GPT and others since, it's really what do we do? And our approach was like the approach hopefully most of you take when you're trying to solve a problem. It's like take a small step. We learned to crawl, then walk and run. Like many of you trying to figure out how do you leverage LLMs? What kind of solutions do you need? Now for Stack Overflow, one of the most important things is accuracy, right? And we know that large language models, as useful as they are, sometimes can be very convincing in non-accurate answers, right? And I think that's really where the RAG solution comes in particular as it relates to Stack Overflow. It's no secret that GPT and Gemini and others have been built on Stack Overflow data. In fact, we're partnering with some of these companies. But it still doesn't provide that attribution back and allow you to figure out the detail of where that answer came from to really ground it in truth. So that's kind of one of the missions we had as we were thinking about the Overflow AI solution. How can we make AI and community better together, so to speak? So I'm going to talk about and demo some of the things that we just released last week with Overflow AI. I'm also going to talk about some things, well, one thing in particular that's not released yet. But this is kind of a selection of the things that we've got, things that we've built, and things that are coming. So in terms of how we got started, we've been working with Elastic for years, right? I mean, they're kind of the default standard in terms of search. And we've been doing textual search, both in our SaaS product and our public site using Elastic for a while. It's been great, right? Now, truth be told, on our public site, most of our traffic comes from Google, people searching and then coming in. But on our proprietary solutions, it's even more important that you're able to find the solutions within your organization. Because it's great to have knowledge, but if you can't find it, it's kind of hard to use. Now, semantic search was new to us. And we thought, OK, well, vector database search, how hard can it be, right? So we started building our own semantic search, right? So we used open source vector database, we used Databricks, we used Unity, and we just started piecing everything together. Now, one of the things that we offer is Stack Overflow for Enterprise. And one of the features or benefits that customers get with that is they get to run it in their own private cloud. So completely isolated, which means we have hundreds of instances. We also have very strict security requirements, SOC 2, ISO, all these things. And as we started working through this and thinking about the complexity of making sure all these things were included and then being able to deploy it repeatedly, it became clear that this probably wasn't going to be the best solution for us. Additionally, Elastic is releasing enterprise search capabilities, which is really interesting to us. And to me, and to us, what that means is being able to search across the business into other data sets, right? So our first step was really implementing an improved search architecture. And you can really just think of this as semantic search coupled with the text search. So you'll notice the diagrams are pretty similar to what Jeff shared because we're following the model in large part almost exactly, right? So in our case, one thing that we did do a little bit differently, so within the Elastic Cloud, you can run hybrid search and they'll do the hybrid and the ranking for you. what we wanted to do is we wanted to pull that out and decouple that. So one of the challenges that we ran into when we were implementing originally was that our model node, so the model that we were using for the embedding, et cetera, would occasionally crash, right? And what would happen is that we wouldn't get any results. And what we wanted to ensure did happen is if something went wrong with either the semantic or the text, we still provided an answer. So we pulled out that search. So we do two different searches. We do the textual, and then we do the semantic. It gives us the opportunity to decouple those, but also re-rank and do the things that we want and apply the business logic. So it's a little bit different than the original implementation. So this was just introducing essentially a hybrid search, an improved search. It was a huge win for our customers, just being able to ask a question as opposed to having to know the right keywords. So the next iteration was enhanced search. And this is what we announced a week ago. And this is really the RAG solution, right? And this is where we're able to use the organization's data as well as public data when somebody asks a question. And in a way, it's a little bit meta here, right? You're asking a question, which is a question. But you ask a question, and then we could generate an answer from the LLM, right? But what we want to do is we want to make sure that we're only providing answers that are grounded in truth, in data that we have access to. So that's stackoverflow.com, and then Stack Overflow for Teams within that engine, within that company's environment. So same kind of thing, we'll index collections, articles, questions, and answers. These are all the things that are within Stack Overflow for Teams that allow us to then create that information, as well as indexing on the public platform, and then be able to search and essentially provide an answer based on the information that we have. So we use the LLM to author the question or the answer, but it's using data from the sources. So the next stage of this is really broadening the scope. So I mentioned that it looks at Stack Overflow for Teams, but one of the things that I think all of us probably experience is information is spread out across the organization. And as CTO, I don't really care that much where my team keeps their documents, where they keep information about how to do things. I just want to make sure that we can find it, right? And so one of the beauties of the features that are coming out is we can integrate that search across other components, other systems in the enterprise. So if you're keeping information in GitHub or Jira or Confluence or any other things, we're able to search that and then use that same augmentation to help provide an answer to the question that you have. And then if it's a question that's going to be repeated, maybe you have to do some work, you can add it to Stack Overflow for Teams, and then you've got all your information there, and or you have that single place to go to find the information regardless of where it sits. I'm super excited about this. I'm going to do a little demo. It's pre-beta, so I'll show a little bit about that, and we're looking to launch that later this summer. So, all right. With that, let me switch over and do a demo. So one of the things, and I got to put my glasses on now. One of the things that's important to us is meeting developers where they are, right? Which means the IDE, it means Slack, the places that most of us are working on a regular basis. So we've built an IDE extension. It's super easy to install, and just go out to usual places, download the extension. And the idea here is we're not a code generator. We're not trying to be Copilot. What we do is help explain things. We help answer questions, allow you to get the information right from within your IDE as opposed to going out to .com or to your Teams instance. So as an example, as a new developer, I might say, want to know, how do I set up my local dev instance, or environment, we'll say. And then you notice we can go across Stack Overflow and Teams, or just Teams. In this case, I'm just going to do our local team. And then the other thing that's worth noting is that this will evolve over time, right? Well, before I get to that, let me just point out a couple of things here. So it's kind of a two-step process. The first thing is we're going to search. And then once we get the top results, we're going to analyze those results to figure out whether those results actually can help answer the question, right? So there's a big distinction or big difference between summarizing the search results and then providing an answer to the question, right? So if all we did was return the top results and summarize them, they may or may not provide the answer, right? I mean, when you're searching, it's not always the top answer that gives you the information you want. So we're trying to interpret that, understand whether or not it's going to answer the question, and then we use that data to summarize the answer. And then what we do is we provide links back to the articles or the question and answer. In this case, it says anonymous, I think because those folks are no longer in the system. But if it was somebody that was still active, you would see the name, you can click on the link, it takes you over to Stack Overflow for Teams, and you can see the answer there. So let me just, I'm gonna do, let's say, okay, I've got my dev environment. How do I do a pull request? So in this case, we're gonna go across Teams and Stack Overflow. So what I was starting to say is over time, the system's built to learn from the questions and answers that are provided, as well as feedback that you will provide. So I mentioned it's analyzing everything here. In this case, it's going against the public platform and the local environment. We're going to generate an answer. And then what I'm going to do is, when it comes back, at the bottom, there's opportunity to provide feedback. And what's really important is that we get this feedback so that we can continue to improve things. But the other thing that's worth mentioning, so you click on the thumbs up, thumbs down, nothing too tricky, but then what are the aspects that are good or bad? And we're kind of looking at the same things. Is it accurate? Is it too long, too short? What's the tone, detail, etc.? But the other thing that you can do here is, let's say it's good. You're like, okay, great, let's submit that. Well, perhaps you want to introduce that information back into your local environment, and you can create what we call an article. So this is essentially a document with information about how to do things. Maybe we're creating a new article on how to do a pull request within Stack Overflow. Essentially, what's going to happen is it's going to pull data from those sources together, templatize it, load it into a text document that then you can go in, edit, and then automatically add back over to the Teams instance. So you can see here that basically it pulled in the information, and it's just kind of a head start if you want to start writing and share that information back into your Teams instance. All right, so that's the IDE. Now this is Stack Overflow for Teams, and I'm going to do kind of a similar example here, where when we first kicked off the initiative, trying to figure out how we wanted to leverage AI for our solutions, we started with a project called Sail. So I'm just going to say, what is Project Sail? Oops. Hit that a little too quickly. You can see with the search from the website, you have the opportunity to search by tags, users. There's a number of different ways of doing this. And then, as I mentioned, you can include the information from Stack Overflow or not. So in this case, it's going to come back. It's going to talk about Sail. It's what does Sail stand for? What are some of the teams, et cetera. And then you have a number of different questions and answers. Let's see here. I am missing something. One thing that I've discovered with the LLMs, one is I can type. Sometimes case matters. We'll see if I get what I'm looking for here. As I mentioned, this is, did I say this was pre-beta beta? All right, so maybe I just didn't scroll down. So basically what we've done here is we've also queried against GitHub. So you can see a number of pull requests from GitHub. You can click on those, go right to it. The idea, like I said, is to be able to make all the information available to you in one place. Right now, we've got GitHub. We're going to be coming out with GitHub, Confluence, and Jira. And there's a number of other connectors that Elastic is building that we're looking to implement to provide this capability going forward. So with that, I think I will turn it back over to you to wrap up.
Great. Switch screens. The right one. All right, that was really awesome. It's really cool integrating all those technologies together. Yeah, I was talking to Jody before, just kind of, he mentioned it, but joke, right when ChatGPT came out, it was that, oh, Stack Overflow is dead, but it's pretty amazing how fast they've pivoted to make it even better. So, yeah, just to wrap up, with Elastic, as you saw for an example, right, we can deliver speed, we're enterprise scale, we've been doing this for a long time, and one thing I want to talk about is, we didn't get into the nuts and bolts of all the super technical things in here because it's the nature of the topic today. We contribute heavily to Lucene. That's the underlying technology that Elasticsearch powers. We're contributors to it and maintainers of it, some of our engineers. Obviously, Elasticsearch, we're making it the most comprehensive, focused on making it the best vector database. And again, partners are really great for us. But on the point about technical innovation, if you are a technical person in the room, I have another slide you can take too. These are some of the innovations that our engineering team have put out just in the last few months. SIMD operations do parallelism across the CPU cores, sharing where we do the HNSW graph for the approximate nearest neighbor, we can shortcut having to search every graph so we can go faster. Int8 scalar quantization, so reducing the RAM requirements down 75%, and we do that automatically, normalizing vectors on ingest automatically, and passage vectors, things like that. So I stole that list from this article. And again, that little sidebar, those are not just chapters, those are individual advances that our engineering team has put forth. So the reason I show this is just to show that we're focused on heavily making advancements to Elasticsearch as a vector database and overall search platform. A couple of cameras. And then I do have one more screen with another QR code. So everyone gets all the QR codes. I'm going to change it because this is on here. This is the last QR code. Search Labs is a technical focused blog microsite we have. It's where we have blog articles, but also a GitHub repository. So we're talking about a lot of the research we're doing, things that we put into Lucene that are going to make it into Elasticsearch. If there's a delay to move up the stack, you can look in there. There's articles on how to operationalize things. I write stuff on there. And then our GitHub has a lot of actual code. You can clone some of the code examples. I think the little example I showed is on there. But to get up and running really fast, Jupyter Notebooks, all that and more, it's a great place. And we are on the 5th floor today. We have a booth. If you go on that 5th floor, right at the hub room, if you walk in and you look to the right, we have some of our great employees over there to help out. So definitely stop by if you have questions. Pretty sure we have stickers. Everyone likes stickers. Yeah, with that, I think we have a minute 56 for, I almost ran all the time. If there's any questions, I know we have some people over there feeding questions.
Just one question, Jeff, if you could repeat it.
Yeah.
Does Elastic have a quick way to test and create RAG applications?
Yeah, so coming out today, and it's already in serverless, we have what we call the playground. It's actually kind of similar. Everyone has like a playground. I don't mean new names, but it's the ability to, if you have documents ingested into Elasticsearch, you can use the UI in Kibana to point at your index, pick your embedding model, and then connect to one of the LLMs. And then test out, your prompts and your chat completions and things like that. The really nice thing about that is when you're done testing it, there's that export button, so it'll dump the code and you can put it right into your application. So it's a nice way to get up and running really quickly, and we build out all the code for you. So, all right, with that, I think just about out of time. Appreciate everyone coming in, sticking around. Thanks to Jody. Great working with you.